Okay, let's talk about the union of two sets and the intersection of two sets. Okay, so the union is the set of all elements contained in either A or B or both. We write that with a U, okay? But in other words, the union is what you get if you toss every number in both sets into a bigger set. Okay. The intersection, on the other hand, is the set of all elements that are in A and B, both. They have to be in both sets. And so we write that with an upside down U, and that indicates the intersection. And so, in other words, the intersection is where the two sets overlap. Okay, so we've got union and intersection. Let's illustrate it with this right here. So find the union and the intersection of these two sets. Okay, so the union is everybody. Okay, so the union is going to be 1, 2, 3, and 4. And oh, I've got to have all those two. I'm not going to list 3 and 4 again, but I am going to list 5 and 6. The intersection is going to be the only thing that they have in common, which is the 3 and the 4. So the intersection is the 3 and the 4. Excuse me. One way to look at this is Venn diagrams. You put the ones that are in both of them here, and then these guys would have a 5 and a 6, and these guys would have the 1 and the 2. So the union is all of this. The whole thing is the union. And the intersection would just be what's in that middle part right there is the intersection. Okay. Okay, that's a visual. Now let's look at it with a bit more mathy. We want the union and the intersection of these sets. Okay, first thing I suggest is you look at these on a number line, because this one starts at negative infinity and it goes to 5, right? Okay, so I'm going to go this way because it's not including 5. But this one starts at 3, which is going to be over here, and it goes to positive infinity. Now, this one is a closed, so that does include 3. All right, now the union means I want all of these and all of these. So the union is going to be from negative infinity to positive infinity because I want all of them. That means I'm going to put it on top of each other and take all of it. The intersection, on the other hand, is just the part that's in both of them. So you can see that if I put these right above each other, right here is the only place that we have both of them. So that's going to be from 3, and I did do a bracket because I want to include 3, and 5 up to 5. Okay, so that's the difference. The union is everybody. The intersection is what's in both. Okay, so let's do a few more problems like this. Okay, now another way to say union is or. That means I want everybody in this set or everybody in that set. In other words, give me them all. And the intersection is and. You've got to be in both sets, this and that, for the intersection. Okay, so let's see how we do this. So let's do x is less than or equal to 1. So we'll have our 1 here, and this is 1. We're going to go this way, which is less than or equal to 1. The other one is x is greater than 4. So I'm just going to put 4 over here, and it's greater than 4. Okay, so that's my second one. Now, this side says I want or. That means I want these guys or these guys. I want any of you guys. I want you all. So that's going to be union. That means, so my answer is going to be both of these. So I'm going to take all of these guys from 1, and I'm going to take all of these guys greater than 4, and that is my solution. So it's going to be negative infinity all the way to 1, union 4 to infinity. That is how I would solve that. All right, now let's look at the other side of the problem because it says and is the intersection. Okay, so I'm going to do the graphs over because it's underneath here. So this one again was everything, here's 1, less than or equal to 1. And this one was everything greater than 4. Okay, now where are the numbers that are in both? Because and means they have to be in both. There aren't any. And so this answer is no solution. Okay, let's do another one. These are a little bit different because I have to get the x by itself first, and then I'll do exactly what I did right here. Okay, so we will subtract 3. We'll get negative 5x is greater than negative 10. When I divide by a negative 5, what happens to my sign? It flips. And a negative divided by a negative is a positive. So I have x is less than 2, or, we're going to do these both ways, but this is my or. Let's minus 2, and we'll get negative x is less than negative 5. And then I'll divide by negative 1, which again flips my sign. And I get x is greater than or equal to 5. All right, now I'm going to graph these. So first we have x is less than 2. So let's put 2 here and 5 here. All right, so x is less than 2 is going to be here. And then right underneath it, I'm going to graph x is greater than or equal to 5, which is going to be this. Okay, or that means I want both of them. I want all of you. So my graph is going to be all of them. So it's going to be less than 2, greater than or equal to 5. And how do I write that with interval notation? I'm out of room. Let's see. See if I can get select. Nope, I don't want to do that right here. Oh, goodness, I'm so sorry. Okay, let's hit, oh gosh. All right, I'm just going to stick it in here. So this is going to be negative infinity to 2 open union, whoops, brackets, because that's including 5 to infinity. There, sorry about my unpreparedness on that. All right, now let's do the same problem only with the word and. All right, so we're going to minus 3 from both sides. I know I already did this, but it doesn't hurt. This is called review. Flip the sign, and this one, negative x is less than or equal to negative 5 divided by negative 1. Flip the sign. Okay, so there we have. We have our two graphs again, and so I'm going to do them a little bit higher. So we're going to put the 2 here, and we want everything less than 2. And then here, we want to put the 5 here. We want everything greater than. And this case, and means the intersection. And sure enough, there is not one again. So there's no solution. So this one had this one had this. Okay. Okay, let's try one more. These are different ones. So give you some different types of examples. Actually, I'll stop the video here and we'll take a break.